Hey YouTube, how's it going? CyberCDH here. I hope you're doing well. Today we're going to take a look at a HTML file, which is pretty heavily obfuscated. So it's a HTML file, but actually the most of the code underneath it is JavaScript. And so we're going to pick apart this JavaScript today. I'm going to show you the methods that the bad guys have used to obfuscate the code, show you the approach that I take to pick this kind of thing apart. So you can apply the same methodologies to samples which are obfuscated in the same way that you may come across in your own environment, or alternatively different samples which use similar methods to obfuscate. You can apply the same tools, tactics and techniques to picking apart the code to see how it all works. Now in this particular case it's a HTML file, and actually it leads to a phishing website, and this is the phishing website here that you see in the background. This sign in with your email, this luno verify.html. And so phishing websites, the fact that it's HTML, it's designed to render in the browser. If you go into your developer tools here, all the elements, all the HTML, the deobfuscated source code, if you like, is all here. So we've actually got the end product of what this HTML file will render in the browser. But what we want to do is satisfy ourselves to understand how it goes from being malicious, which is all of this stuff here, obfuscated, how it goes from this obfuscated format, and you can see it's pretty crazy, into something that looks like this. So this was actually a request from a follower of mine on Twitter. I do get these from time to time quite regularly, and I don't unfortunately have time to look at all of them, but this one I spent an hour or so looking at, and I thought it's actually quite a neat little algorithm to pick apart and showcase the approach that I would take to looking at malicious JavaScript. In this particular case it's a phishing website. So we won't analyze the phishing site itself in this particular case, although that's quite a good topic to further explore. As I say, we will further have a look at how it renders this HTML, converts all of this weird stuff into valid HTML. I'll show you the algorithm that's used and the packer that's used to obfuscate it. You want to play along at home, you should get yourself a VPN first off. Use a virtual machine. I use VMware Fusion, but you can use anything, Hyper-V, VirtualBox, or Parallels, whatever. And get yourself an operating system. Obviously on there I use Windows 10. You can use Linux distro if you wanted to. I use a browser, Chrome, and I also use Burp Suite Community Edition here, which is free of charge as well. So you can do all of this for free and follow along. So here's the phishing site and the malicious file itself. So I'm viewing this on my host, but I'll be running the code, etc., in my virtual machine. I just find it nice and easy to look at natively in my on my MacBook here. If you want to use a good text editor as well, Sublime Text is the one that I would recommend. So this code actually starts with like a lot of, you get this like weird purposely entered error message, and then like 4,500 or whatever empty lines before you actually get to the packed obfuscated code. That's probably a deterrent from, if you're a security analyst and someone sent this file in as a malicious attachment to say they got a weird email and you were the incident responder, you probably look at it, open it and think, well, there's nothing here, so therefore it must be blank. And not many people would keep scrolling and scrolling until they find the obfuscated code. So it's quite an interesting technique. So let's copy it into a new file. I use a plugin called Prettify in Sublime, which you press Command Shift and H on, and it will prettify the code, whether it's HTML, CSS, or JavaScript. And it does a pretty good job. It doesn't do everything for us, but it does a pretty good job at making it a lot more readable. And we can see here that we're in there's a function here called gx38, and then that function is called numerous times throughout the course of the code here. So that looks to be the main deobfuscating routine that we need to focus on. So that's where we're going to spend most of our time here, is working out what this function does. And there's only a few lines or so, or is it like 10 lines of code or something? So not too much to burn ourselves out with. You can see there's a couple of little functions here where it just stitches a couple of strings together. That's nice and easy to tidy up. And really that's what I'm doing first pass, is I want to make sure that I can read this code to begin with. And you can see these lines are still a bit messy. I mean, there's a for loop here, so press enter and then Control Shift H again, and it will format it up nicely just to put the code in a bit more of a readable format. So that looks a bit nicer to me. We've got a couple of declarations here, if condition, and then outside of the for loop, this is the final thing that I'll execute. Okay, so let's pick it apart then. So you call this function, and it takes in one variable, one argument, which is this big long string, and the next one will be another big long string, etc. Declares a function, stores it in WHBJ, declares a few variables, one of which is a big long wonderful string here. Thing to note about this one is if you highlight all of that text, you'll see Sublime, in fact without the quotes, if Sublime thinks it's, you can just see behind me, 97 characters, and the length of this string is stored in here, this variable QS3C. It's not actually 97 characters long, and I'll tell you for why. So if we, I'll prove to you actually, let me come here into my virtual machine here, and then come into our developer console. Let's go to our console window, get rid of that. So here's the string, and we say type it properly, .length. You can see this, the length is actually 93, and that's because of these escape characters. So in order to have a new line character, or a single quote, or a double quote, or a carriage return, you need to escape those characters, because if you didn't, you would break the string up, and that wouldn't work. So we got 4 of them. So you've got Sublime thinks it's 97 characters, and it is in the literal sense, but it's 93 actual characters in the ASCII table. So the length of that string, make a comment here, is 93. We get this object jmon, which is declared with an empty key value pair of CD, which is blank at the moment. And then we get this new function here, which just returns unescape. So it's called UE, and it returns unescape. So UE no doubt stands for unescape. And we can see here that there's another new function called FGPA. It takes one variable, which is stored in the parameter x, and the return is and it unescapes this particular string here. So we can unescape it in our window here actually, and that equates to this.cd plus equals x. So I can replace that, and so we have here a little bit of shorthand notation, plus equals x. So if you have like x plus equals y, that's the same as saying x equals x plus y. It's just shorthand notation in JavaScript. So in here, what's going to happen is we have this.cd plus equals x. So what it really means is this.cd plus this.cd equals this.cd plus x. So it's just going to add whatever's already in CD. It's just going to add x to it. So it's just going to concatenate the value of this.cd and just add onto the end of it whatever we pass into this particular function as x. Next one, UB70, is another new function. This time takes 2 parameters, x and y, and we can see here that they've tried to obfuscate it using this unescape routine as well, but we can unescape it ourselves, and that equates to return x.char at y. I'll explain what that means as well. So this function takes 2 parameters, x and y, and it returns. So it takes x and then applies .char at y to it, and what it means is x is a string, and it says give me the character at index of y. And what I mean by that is, let's say our string is, type it properly, hello, and you want char at index 0. So you can see that the character at index 0 is h. Character index 1 would be e. Character index 5 would be nothing, because we got 0, 1, 2, 3, 4 is the length of our array. So 4 would be O. So give me the character at index y is what that's saying. So there is all our declarations done and dusted up here, and here we get into the meat of it. So we go through a for loop, and the for loop takes a counter stored in fn9n. It goes from 0 up to the length of the argument that we pass in. So this big weird and wonderful string here. So it's gonna. So in this case, what was that? Like 2000 and something. 2092 minus the escape character, so 2000 and whatever, AE or something. That it's going to loop through that for loop that number of times. It's going to take it in single step increments here, and we have a declaration of LPE7, and it's a function which is passed an x and a y parameter. So in this case, x is the big long string that we pass as a variable to the main function, and it says give me the character at position y, at index y, and y in this case is the loop counter. And so the first iteration of the loop, fn9n, is going to be 0, and then therefore it's going to give you the character at position 0 from this big long string, which in this case is a closed bracket. The next iteration of the loop will be position 1, so it'll be that one. Position 2 it'll be a P, then it'll be an S, then it'll be a H, then it'll be a K, etc. So all this is doing is reading our big long massive string here, this ugly thing. It's just reading it in one character at a time and storing it in this variable. So in this case, the first iteration of the loop, it's a closed bracket. Then you get kujp, and what it does is it takes our this weird string, which I'm going to refer to as an alphabet, and it says, right, give me the index of that character that we just looked up. So at what index does that character appear? And what I mean by index is what position does it appear, and returns an integer value. So it's going to look up, in the first iteration of the loop, it's going to look up this closed bracket. It's actually going to find it at position 0, and therefore it's going to say it's 0. You know, the second iteration of the loop, it will say, right, yeah, that's 0 as well. Third iteration, it's going to look up the capital P, and therefore it's going to look up in here and look for the capital P, find it all the way over here, and find that it's, let me work it out properly. Here we go, we got 1, 2, 3 escape characters, so it's at position 75, for example, in this particular example. But stick with the first iteration of the loop. The closing bracket is at position 0, and that's stored in kujp. If, for whatever reason, there's a character in here, I can see already there's an @ symbol, for example, and an @ symbol does not appear. Oh, it does, I beg your pardon. Maybe there's another character here, maybe there's a $ or something. I haven't been through all of these, as you can imagine it'd be pretty tedious. But if there's a character in here that doesn't exist, then the return value of index of would actually be -1. So here's a check to say that if it's greater than -1, i.e. it has been found and there's a position number returned in this kujp, then this is the next most important line of code that we need to deal with. It says, right, okay, well kujp minus equals, so remember we had x plus equals y before, well x minus equals y is the same as saying x equals x minus y. So in this particular case, kujp, let me write it out, kujp equals whatever the value of kujp is at the moment, which we know on the first iteration is 0, and then it's going to minus fn9n, which is the loop counter. So we're on the first iteration of the loop, so we're at 0, plus 1. And forget this bit for 1 second. So we got 0 minus 1, which is obviously -1. And then we have this %QS3C thing. And you can see here that that's stored, that's the length of this string, which was 93. So you have -1 modulo 93. Well, it's meant to be modulo, and there's a little quirk here in JavaScript that JavaScript doesn't have a modulo operator, and so there's a little bit of a fudge, but I'll explain that in just 1 second. So if we take that value here, and let's just type it into Google's calculator, we can see that -1 modulo 93 is 92. And you might wonder what modulo arithmetic is all about. Let's do 13 mod 12. 13 mod 12 is 1. This is just a kind of silly example to explain what modulo arithmetic is all about. And you might think this is familiar. Imagine this was a clock. Sometimes this is called clock arithmetic or clock maths. So you have 13, but if you have only 12 positions on a clock, well, you've got to wrap around somewhere. So what's the remainder, basically? And the remainder here is indeed 1. So the difference between 12 and 13 would be 1. So if you get to 1 o'clock, but if you've got like only a 12-hour clock, then it's actually going to go back to position 1. And so that's what we're saying here. So if we've got -1 modulo 93, well, it's going to wrap around. You've got a maximum of 93, and it's going to wrap around from 0 to 93, and it's going to wrap around that value. So it's going to come back to 92. So going back to our example here, What actually happens in JavaScript though, it's a little bit of a quirk. Let me clear the console. If you do this particular calculation in your console window, you can see, let me get rid of equals, beg your pardon. You can see that -1 modulo 93 in the JavaScript console here still comes out at -1, which is not quite right. It's not what we want. We want the modulo. And so what the bad guys have done, let me get rid of these lines of code here, is to say if kujp is less than 0, which in this case it is because it's -1, then add to it the length of the string, which is 93. So it's a fudge basically to force the modulo in this kind of corner case where you end up with a minus value. So you get -1 plus 93, which is obviously 92, which is what Google was telling us is the actual result that we need here. So we've got 92. What happens with that then? So you have a call here to a function fgpa, which is a new object. It takes one parameter and it updates the value of this.cd, and the value of this applies to this object here, jmum. So this applies to jmum. CD is a key value pair stored within it, and so it's going to update here. As I say, it takes one parameter, which is x, and applies this.cd plus equals x. So appends to CD whatever it is the argument that we're passing in, and in this particular case, it's going to be whatever this equates to. And in this case, we've seen this function before. This is the return x.char at y, and so in here, it's going to take our alphabet, and it's going to get the whatever character appears at the position that we've just calculated. So in this case, 92. So on the first iteration of the loop, it's going to work out. It's going to go, okay, give me whatever is at position 92. Now remember, this is 93 characters long, so index 92 is actually the final character. In this case, it's a open angle bracket. And it's going to apply that. It's going to update the value of this.cd, so which is in here. It's going to be stored in jmum, and it's going to store the angle bracket in here. The next iteration of the loop, we have another angle bracket, and it's going to go through all this again. It's going to find where it's at, what index applies to kujp, applying the same modulo arithmetic, update that value, and in this particular case, it's going to come out with a lowercase h, etc., etc. And it's going to come out and fully update this CD variable here. So that's the main algorithm. And then at the bottom, once we've been through all of the iterations of the loop and come out of the for loop, you can see here there's another string that gets unescaped. So let's unescape this in our browser here. And that equates to document.write this.cd, which basically means write or whatever is stored in this.cd, because it's now going to be fully populated. So whatever's written in this.cd, write it to the document and then set it to null, because we get another call to this.cd, so we don't want to confuse it. So what we can actually do, if you wanted to see this in action, we can console.log jmum.cd. So let me just make sure I haven't inserted any incorrect code here. So we can copy out this function, paste it into the console window. Let me clear the console so it's a bit clearer, and then apply this particular call to JX38, and there you go. There's the HTML that all that weird and wonderful stuff equates to. So you've just deobfuscated it yourself. And it's a bit of a clue in this particular example as to what method the bad guys have used here to actually protect their HTML code. So you can see here it says this page has been protected with a demo version of htmlguard.com. So if you went in your browser to htmlguard.com, you can see this is a tool for Windows which protects your website's images, text, and code from being copied. And so that's the algorithm that's been applied to the bad guys' phishing web page in order to actually protect it. So there you go. That's how you would deobfuscate it. Obviously, as I say, in your browser, you've got the finished product within the elements already, in the elements tab in your console window here. So you have the finished product, but now hopefully you understand the algorithm that's being applied here to actually take weird and wonderful strings like this and convert it into valid HTML. One final thought, just to kind of wrap it up. what's actually going on under the hood here is whatever position we're at in this big long argument that gets pushed as a parameter to this function. So let's say we're on the 5th iteration of the loop. Then what's actually going to happen is it's going to find where that character exists and take the 5 + 1 steps back. So if you're on the 5th iteration, it will take 6 steps back. If you're on the 7th or 8th or 100th character in this particular string, it's going to take 100 steps back, or 101 steps back, I beg your pardon, but modulo 93, modulo the length of it. So it'll always wrap around and stay within the bounds of this particular alphabet. So quite a nifty use of modulo arithmetic there, and hopefully now you understand how you can quite simply pick it apart and deobfuscate it. So hopefully that was useful. Glad to be back with you guys. Take it easy, and I look forward to sharing another video with you soon. Cheers.